This video will show a workflow using the oil IPR TPC analysis method. In this example, we want to see if our oil reservoir would be a good candidate for gas lift. The details of the well are shown in the following slides, including fluid properties, wellbore configuration, and reservoir information. Now shown is Harmony's default screen layout. To get started, add a well in the Entity Viewer and launch it. To add a well, click on the plus button and follow the prompts. We want oil flowing. To launch it, double-click on the well. The initial screen we come to shows a list of analyses possible. But before we can perform the analysis, we need to set up the properties and wellbore configuration in the Editors tab. Here are the oil properties, and here's the completed wellbore information. Now that the properties and wellbore editor have been populated, we can analyze this problem. Go to the Add Worksheet page, click on the oil IPR TPC thumbnail, then add an analysis by going to the plus button and selecting the desired analysis. We will create oil deliverability Vogel. First, enter the IPR data. We need the reservoir pressure, the sand face flowing pressure, and the test rate. As soon as all the fields are populated with data, the IPR will be drawn. Now let's create a tubing performance curve that represents the current state of the well. Add a new analysis called Oil Tubing Performance Curve, again using the plus button. Enter the wellhead pressure, gas-oil ratio, and water-oil ratio. Since we only have one wellbore configuration, it has been automatically chosen down here. However, if more wellbore configurations were added, they could be selected from these drop-down menus. Once the information has all been added, then a tubing performance curve is drawn. Of key importance is the intersection between the two lines, which is called the operating point. Hovering over the operating point with a mouse will display the intersection data. At this point, we have created our base situation. By adding additional curves with different gas-oil ratios, we can simulate gas lift and determine the sensitivity of the system. Let's add another TPC by using the plus sign to add another analysis. Now we can add the data in again manually, or we can copy from the previous TPC by clicking here. To simulate gas lift, just increase the gas-oil ratio. Let's try 500 scuff per barrel for this curve. For this example, adding gas lift appears to make a sizable increase in production rate, which could be profitable depending upon the availability of injection gas. Now that we know the well is a good candidate for gas lift, the next question is how much gas to inject. Let's see what happens if we double or even quadruple the amount of gas injected. To do so, repeat the previous steps using gas-oil ratios of 1,000 scuff per barrel and 2,000 scuff per barrel. It is apparent that as we add more gas, production does increase. But the returns are getting smaller and smaller. The optimal choice depends on outside factors, such as gas availability and cost, rate limitations, or other details.